Alright, we are on the last of 3 videos that are examples for Worksheet 8.1 in Algebra 2. And this one covers problems 21 and 22 on the worksheet. Okay, what we have is a state that's decreasing in population. So the population is going down. And it's decreasing by 2.4% per year. And the initial population was 285,300, and that would be in 2018. So what's the predicted population 10 years later in 2028? Alright, so the first order is to find the base. And the base here is going to be 100% decreased by 2.4% per year. So we're going to go ahead and do this subtraction here. It's going to be 97.6 or 97.6%. And you're going to lose this percent sign, so move your decimal to the left. Here's your base, 0.976. We have an initial amount or a starting amount in 2018 of 285,300. So that's your A value. And you're going to set it up like this. Y equals AB to the X. You're always using that formula. So it's going to be Y equals A, 285,300, times the base, 0.976 to the X power. So there's the equation we're going to be using, and we will simply put in 10 for the X value in this year. That's 10 years after the initial year. So we're going to use 10 there, and that'll finally do it for us. 285,300 times 0.976 to the 10th power, and we'll have our answer. So let me type this in using the home screen here. And I'm using the exponent key over here on the right. So my final answer here is, I'm just going to round this off a little bit, 223,700 and I'll go ahead with 69 here. The decimals don't make any sense because these are people and we don't want to chop people up. Quite practical. You'll end up in jail if you do. Okay. The colony of bacteria is growing at a rate of 35% per day. So this thing is really skyrocketing because that's a huge percentage of increase each time. And they don't count individual bacterium. They weigh the whole pile, okay? So the starting original amount of this thing was 3.8 grams of bacteria. So that's your A value, measured in grams. But let's take this base and convert it into a usable number here. It's an increase of 35%. Which is the same as 135%. And to make this usable, we're going to lose this percent sign, which will move the decimal to the left 2 spots. So there's your base. There's the A value, and we're going to go ahead and set up our formula here. A is 3.8 grams, the base is 1.35, and we're going to use an X value here that they tell us. 6 days later. So we'll put a 6 up there, and that'll tell us the answer we're looking for. So all I have to do is type this in. 3.8 times our growth factor of 1.35. That's a huge growth factor. And we'll go to the 6th power. So after 6 days, let's see how many grams of bacteria we have. Roughly 23 grams of bacteria. Okay, so that does it for problems 21 and 22 on your homework. And I hope this helps you conquer those problems.